Here's the problem that I aim to solve today. I use a lot of drawings, but they're not interesting for video. Animations are interesting for video. I can't make animations. Welcome to my cave, where I'm going to be taking on some hopefully interesting projects of dubious potential. Given that this is a new channel, there are many things that I need, the foremost being skill at content creation. As an engineer, however, designing things to make up for lack of skill is my forte. Apparently, a lot of YouTube viewers need flashy, moving things on screen at all times to occupy their goldfish-like attention span. I'm sure that doesn't apply to you since you've already made it past the 30-second point. I could spend a lot of time and money buying and learning some professional software like After Effects, but where's the fun in that? It'd be much more dubious to try to create something myself, in a day. The first thing I always try to create is a project scope, otherwise I'll never finish anything. So here are my requirements. I need to do drawings on my PC. It must be touchscreen compatible, therefore no right clicks, no middle clicks. The drawings need to have motion. The software needs to be simple and fast to use. It needs to create both stills and videos. I want to be able to choose colours and brush sizes. And I want to choose the background, whether it be block colour, images, or just transparent. I need to write it in a day, which I'll call 8 hours like it's a work day. This means no learning new languages and no external libraries. I've chosen the processing language for this project. It's free and open source, pretty simple, and has loads of built-in graphics capability. I'm just going to hack together the basics of how I think this program's going to work and then take it from there. This seems like a great place to stop and explain what I've done so far. Don't worry, I won't be going through it line by line. I'm just going to do a quick top-level overview of the structure and the principles. And what better chance to use my program to try to explain to you in pictures what I would otherwise fumble to put into words. Processing has two useful system variables called mouse X and mouse Y that store the cursor's current screen coordinates. Using this, it's easy to draw a dot at that exact position on screen when the mouse or touchscreen are clicked or held. Overlapping dots created as the cursor moves across the screen give the impression of there being a continuous line. This is better than creating an actual line because it makes animation very simple and smooth. I did have a problem with that approach to start with. If the cursor moves fast, then the line gets broken and becomes individual dots again, which looks rubbish. It turns out that the mouse X and mouse Y variables are only updated once per screen refresh, and even at high refresh rates it's more than possible to move the mouse many pixels per frame. There are probably a ton of solutions to this gappy line problem. What I decided to do was a bit of trigonometry, because trig's cool. If you look at the previous cursor position compared to the current one, you'll be able to work out the distance between the two positions using Pythagoras' theorem. Or you could cheat like I did and use processing's built-in dist function. Using the distance in pixels, which I'll call d, it's possible to move 1 over d times x by 1 over d times y, which will land you at a new location 1 pixel along the direct path between the old and new cursor positions, where it'd be just perfect to draw an in-betweeny dot. Now, all that remains is to repeat that lerp d times, drawing a dot at every step, and voila! A perfectly unbroken line between 2 points, even if the points are miles apart. Processing's map function made this far too easy. After I had the dots and lines drawing fine to the screen, I decided to wrap everything up in classes to make things easier later on. The board class represents everything that's drawn to the board. Oh, did I mention that I decided to theme this program like it's a traditional school blackboard? There's only ever one board object which contains a scalable table of line objects. Line holds the colour and diameter of the dots, and its own expanding table for dot objects. Dots hold the XY coordinate of a dot, as they jolly well should. So what we've got is lots of dots in each line and lots of lines in the board. Oh, and one more detail I'll add while I'm talking about the board: how the board knows when to create a new line or continue to add dots to the old one. When the cursor's moved but not dragged, it sets a flag in board indicating that a new line's necessary. Next time a click or touch happens, that flag gets checked. If it's false, then a new dot will be added to the last line. But if the flag's true, it gets a new line added and then the dot ends up there instead. I even got to use a recursive function here, because recursive functions are cool. After creating the class structure, I was ready for the playback animation. When I press R, the screen clears. I made counters to keep track of the current line and the dot within that line that need drawing. These counters are initially set to 0, so they start out pointing at the first dot of the first line. By fetching the line at the line counter and its dot at the dot counter, I can draw everything back in the order it was created, one dot at a time. Each time a dot's drawn, the dot counter increments. When this value exceeds the size of the dots table, it gets reset to 0, and the line counter gets incremented instead. When the line counter runs past the end of the lines table, the program knows there's nothing left to draw and it can end the playback. While I'm sketching, I might as well explain how I think the save and open functions all work, which is where the class structure will really come in handy. I'm probably going to use the JSON format for the files because JSONs are cool. A toJSON method in each class will let me replicate the existing structure of board, line, and dot. Dots method will wrap up the X and Y values as a little baby JSON object and return it. Lines toJSON will wrap up all of the baby JSONs from the dots, as well as the colour and size. Board's equivalent method will return a big daddy JSON stuffed full of all the lines JSONs, each in turn containing all of their baby dots. So one call to board can deliver all the coordinates, colours and sizes of the drawing, no matter how complicated it gets. All ready to be saved as a text file. Shiny! The open function should be the same as the save, but in reverse. When a file's loaded, the board will have to clear all the existing lines, then for each line in the JSON, it can add a new line object to the table. That object can then create all of the dot objects, and so on. It should be pretty straightforward. So with that all sorted, it's time for me to write some more code. Cue music. I should never have said that open would be easy. That completely jinxed it. I had a really frustrating hour swearing and trying to work out why half of every drawing seemed to disappear when loading, despite the files being complete. As it turns out, processing's load.json function doesn't wait for the file to be fully loaded before returning that it's done. So there's clearly some threaded, timey-wimey stuff happening under the surface. My crude and uncivilized fix was to slap half a second's delay between load.json and the using of that data, just to give my SSD and RAM a chance to have a good natter and maybe a nice cup of tea. Other than that, it all went well, and I finished in the nick of time. There are a couple more features I'd like to add, like checking file extensions and maybe a redo to go with the undo that I already wrote. It'd be brilliant to be able to drag and reposition lines that are already drawn, but all that can be added another time. According to my original requirements, it's all here. And I'm actually very happy with the results. This is a really useful tool that I'm sure I'll get loads of use from in future videos. If you want to have a play with the processing language I've been using, you can download it for free at processing.org. I absolutely recommend having a look at Dan Schiffman's channel, The Coding Train, for a great tutorial series on the language, so I'll put links in the description below. All my code's available on GitHub for you to use and abuse as you see fit. I don't know why you'd want to, but it's there. I enjoyed making it, and I hope you found it somewhat entertaining to watch me write it. I look forward to taking on some more challenges, especially ones that aren't purely programming, so that I can break out some tools and some 3D printers, so please click on the subscribe button if that's the kind of thing you want to see, and leave a comment below if you have any project suggestions. I'll let this video play out with mine and my daughter's very nerdy beta test of this software. Take care and see you next time.